Let's just get some geometry lines and angles practice. Now I hope that what you'll do before you run this video is that you'll go through this whole worksheet and you'll look at these questions and answer them. Periodically there's some letters that I need to add, and just now I added the letter E right here in this picture. So again, hit the pause button from time to time. In this picture, I'm looking for you to describe an angle that is an obtuse angle. So I need that angle to be greater than 90 degrees and less than 180 degrees. And the only option for that is this line right here. So BC with EB. You can write that angle that is greater than 90 but less than 180 as either angle BC, or you can write that as angle CBE. Bottom line is just that the vertex has to be in the center and these letters can be interchanged. Next, from this picture, I'd like you to describe any of the acute angles, and actually there are two. I'm not going to write them in both of their names, but I'm just going to write one version of each. An acute angle is something less than 90 degrees, so ABE would be an example of an acute angle. So would DBE be an example of acute angle. Again, you can write those in their other form as well. Just make sure that the vertex is in the center. So ABE and angle DBE are both acute angles. And then line ABC is a straight line. And because of this box right here, I know that CBD is a right angle. And since this is a straight angle, I know that this is also a right angle, ABD. So there are two, angle ABD or DBA and angle CBD or DBC. Okay, from this picture, I'm going to ask you what angle is a supplementary angle to a 75-degree angle. And I'm sorry, not from the picture. I just want to know, if you have a 75-degree angle, what angle would be supplementary to it? And I'm going to attempt to draw a picture of this. So supplementary angles are 180 degrees in total, and so a 75-degree angle might look like, that line moved on me a little bit, but this might look like the 75-degree angle. So I'm asking you to tell me the size of this angle right here, and these two have to add to be 180. So I'm hoping you are thinking 180 minus 75 would give you 105 degrees. Complementary angles should add to be 90 degrees. So I want to know what the complement is to 41. So if you took 90 and subtracted 41, you would get 49 degrees. And these two would be complementary angles. Okay, it's given the picture on the next page, I'm afraid. I want to find the measure of these angles, DOA, BOE, and AOE. So what I'm going to do is I'm going to turn to the next page and then rewrite the questions down. So, and then I do need to label the letters on this picture. So I'm going to put O as the vertex right here, A is right here, B is right here, E is right here, and what I'm asking you to find again is what is the size of angle DOA, what is the size of angle BOE, what is the size of angle AOE, all of that with the fact that this is a right angle, these are perpendicular lines, and that this angle is 25 degrees. I'm going to try to rewrite that. Again, this angle is 25 degrees. So let's see. DOA. DOA is the complement to this 25-degree angle. Because this is a right angle, then these two have to add to be 90 degrees. So angle DOA, maybe I'll write it right here, could be found by taking 90 degrees and subtracting 25, which is 65 degrees. Okay, BOE. BOE. BOE is right here, and you see this 25 degrees over here? That's a vertical angle, and vertical angles are equal to one another, and they're formed by two straight lines that intersect one another, and they are on opposite sides of that crossing point. So angle BOE is a 25 degree angle. AOE. AOE. AOE has got to be the sum of this right angle and this angle right here. We already found DOA to be 65 degrees, so it's got to be 90 plus 65 for a total of 155 degrees. Okay, let's see if we can get these next two problems done fairly quickly. Pretty challenging though, I must admit. Here's the numbers that I'm giving you. This is 18 degrees. This is 72 degrees. This is called angle 1, 2, 3, and angle 4. Okay, so first of all, see this 18 degrees? Therefore, angle 1 has to be what? Yes, 18 degrees. Some people then think angle 3 would be 18 degrees. That is not the case. They look alike. Please don't ever assume that because something looks alike or looks about that size that they must be the same. What you have to do in reality here is you've got to find angle 2 next. And you're going to find that because the 72 degree angle and angle 2 add to be 180. So you can find the size of angle 2 by taking 180 degrees and subtracting 72 and getting 108 degrees. All right, angle 3 is going to be found now by adding up so that the sum of the three angles in the triangle add up to be 180. So that's something we haven't talked about yet, but you need to know that angle 1 plus angle 2 plus angle 3 needs to be equal to 180 degrees because that is always the sum of the angles in a triangle. So what I'm going to ask you to do is to add angle 1, which is 18, angle 2, which is 108, add those together and get 126. And then subtract that 126 from 180, and I think you'll get 54 degrees. So that now 1, 2, and 3 add up to be 180 degrees. With angle 3 being 54 degrees, I can find angle 4 now by taking 180 degrees and subtracting 54 degrees because these two are formed by a straight line and they must add to be 180. So again, angle 4 is 180 minus the 54, which is 126 degrees. So I'm just trying to look into some pictures and see vertical angles and supplementary and complementary angles, see triangles with them to discern the size or measure of some angles within a triangle. The last one that you would practice with. What I want you to know about this is that line 1 is parallel to line 2, first of all. Line 1 is parallel to line 2. This is a right angle, and it's not drawn real well. It doesn't really look like a right angle, but I'm going to call that a right angle. I'm going to call this angle 1. This is 68 degrees. This is going to be called angle 3, angle 4, and way over here, angle 2. All right, so angle 1 must be 68 because of this 68. Vertical angles. Since line 1 is parallel to line 2, then this angle and this angle are called alternate interior angles, and they are equal to one another. So this is equal to 68 degrees because angle 1 is equal to 68 degrees. So is this. So angle 2, since it's formed with the 68 degree angle, and this is a straight line, angle 2 would be found by taking 180 minus 68 and getting 112 degrees. Do you see this 90 degree angle right here? And we have this 68 degree angle. The sum of these three has to be 180. This one's 90. So if this one's 90, then these two have to add to be 90. They're the acute angles in a right triangle. So for that to be the case, if I took 90 and subtracted the 68, I'd get 22 degrees. That's just faster than adding 90 and 68 and getting 158 and subtracting that from 180. Angle 3 and 4 need to add up to be 180. Since I know angle 3 is 22 degrees, then angle 4 would be 180 minus those 22 degrees and give me 158 degrees. A lot of work with angles during this unit. We're going to go on to our next unit and study right triangles, which is quite fun in the Pythagorean theorem.